Going on, guys? My name is Johnny Bandon, and I'm the CCNA instructor for this video series. In this video, we're going to be going over IPv4 addressing. And again, our first section here in the CCNA exam is one of the most important because we have to understand our fundamentals and the basic core networking principles before we move on to more advanced stuff. So let's go ahead and just tackle this section and let's begin. So I'm going to move this out of the way down below here. Let's dive right into IPv4 addressing. So the first thing we're going to do is go over a quick overview of IPv4. So what is it? At a very high level, a 50,000-foot view, IPv4 is the internet protocol that is the standard protocol for delivering traffic across the internet, right? And of course, we have version 6, which is going to be in a totally different lesson. But that is what IPv4 is, the internet protocol. Think of this as a way, it's like your address at your home. How do we know where to send mail? Because we have a mailing address. That is what an IP address is for a device connected to your network or the internet. Now, what is the IPv4 address? Well, to know what it is, we first got to understand what binary is, ones and zeros, right? And computer language, or how do machines talk? So an IPv4 address is a 32-bit address that gives your network device a unique identity, right? We've already said an IP address is like your mailing address, right? We read an IP address in what we call dotted decimal format, which is 4 sections, numbers 0 through 255. Now, the actual IPv4 address is, again, going to be 32 bits, and we split those 32 bits into 4 different sections of 8 bits we call octets. And again, 8 bits equals 1 byte. So an IP address is either 4 bytes, 32 bits, or it's presented in this dotted decimal format. Okay. So that's a quick high-level overview of IPv4. Now let's get into what binary is. Because to understand IPv4 and later on subnetting and the different types of addresses, we have to know what binary is. So binary is a numbering system of ones and zeros called bits. These bits are what computers use. It's machine language, right? What they use to communicate with each other. So bits is machine language. As humans, we don't know bits, right? We have to convert these ones and zeros into dotted decimal to understand an IP address. So again, with binary, the 1 bit equals on and the 0 bit equals off. So now, for the IP address or the decimal numbering system, it's going to consist of 10 digits, 0 through 9. Now what? 0 through 9? That's right. In computer language or in machine language and technology, that 0 counts as a number. So if we were to count on our fingers, right, 0 through 9, and we count the number 0, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 fingers, right? But 0 through 9 is 10 digits, okay? Now, since this is a network administrator course, we're only going to deal with binary as it relates to IPv4 and IPv6, okay? So again, let's take this a step back again. So bits, they're either ones and zeros. Ones is the on bit, 0 is the off bit. And this is how computers and machines communicate. All your data can be broken down into bits, right? And then when we start categorizing our bits or putting them into, segments, right? 8 bits equals a byte, right? And then if we get into our different speeds, like we'll go over in our, or we have been over in our lessons, 1,000 bytes equals what? A kilobyte. And then depending who you ask, 1,000 kilobytes or 1,024 kilobytes equals what? 1 megabyte. Okay? And then again, with bits, we also have kilobit speeds and megabit speeds. Again, kind of beyond the scope of this lesson. But when we're working with binary and networking, we're mainly dealing with how it relates to an IP address. So again, an IP address is a 32-bit address that's going to identify a host. These 32 bits, we convert them into what's called dotted decimal by separating them into 8-bit segments 4 times. So we have 4 sections or segments here of 8 bits. And we convert those bits into regular numbers just like me and you are used to. And we call this format dotted decimal. Awesome. Now, how do we convert binary into dotted decimal? Let me go to my next slide to go over this, because we're going to need to use something called the binary positional table. So, how do we do our binary to decimal conversion? To convert an IPv4 address to its dotted decimal equivalent, again, we're going to divide the IPv4 address into 4-bit octets. So this is kind of showing you how to convert decimal right here, right? Or excuse me, binary into decimal. So let's do it. So now we have these 32 bits. And we have our binary positional values here, or our binary table. And again, we go in powers of 2s for bits, guys. Again, I've sat through a lot of courses that go over these powers of 2s. And for a CCNA course that's just trying to get you certified, diving into the math of it may be important for some instructors, some teachers that truly want to get you in-depth knowledge, right? But again, we're going over what the CCNA exam objectives want us to go into. So if you notice, each bit is in the powers of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. So you'll notice this is 2 to the 2nd, 3rd, to the 4th, to the 5th, 2 to the 6th, and 2 to the 7th, okay? If you need to know how we get our binary positional values, that's what we do. We're going powers of 2s on our bits, right? Okay. So let me clear this up a little bit. All right. So now let's do our first conversion. So what we're going to do is I'm going to rewrite this here just so you can see me doing it. We're going to take these first 8 bits in our IP address and our first octet. And again, yes, I'm going to keep repeating the vernacular, right? And we're going to place it underneath our binary positional table. So here we have 1, 1, and then 0, 0, 0, 0, 0, 0. Now again, 1 is our what? On bit. 0 is our off bit. So if we have a 1 bit underneath this number 128, that means yes, that bit equals 128. This bit equals 64. And then the rest of these are off bits, so their value is 0. So now if we drag all this down, say, okay, out of these 8 bits, our 2 on bits represent 128 and 64. The rest are our off bits that, of course, are just 0. And if we add this up, 128 plus 64 is 192. And then plus 6 other zeros is still 192. So we just converted that first octet. Now let me clear the screen. Let's do this again for the second one. So I'm going to write our binary value or table over here. Again, this is how we convert binary to decimal. And I'm going to place this second octet underneath our chart here. You have to memorize this chart, especially when we get to subnetting, okay? So we got 1, 0, 1, 0, 1, 0, 0. So now if we bring these down, we have 128 plus 32, because again, our on bits represent those numbers, plus 8. And now let's do some public math. Scary, right? 128 plus 32 is 160, plus 8 is 168. So now our second octet and that IP address is 168. Awesome, guys. So now, let me make sure I'm not getting ahead of my slides. No, I was. Now let's do decimal to binary conversion. So how do we go from binary, right? Or excuse me. How do we go from decimal to binary, right? Well, let's do it here. Okay. So if we have, let's say, is the decimal n greater than or equal to 128? No. Then let's go ahead and do our conversions, right? So let's say we have the number 140. And we got to figure out what that is in binary. What we're going to do is write out our chart. Again, you have to memorize this. And then we're going to take that decimal number, because we have to get the binary, right? And we're going to place it right over this 128. And we're going to ask ourselves, is the decimal number 140 greater than or equal to 128? It's greater than. So that means we're going to put a 1 bit. If this binary positional number, the chart, can go into 140, or if this decimal number is greater than this chart number, on bit. So now we take this original number, minus it from 128, and we get the number 12. So now, right, the number 12 is our new decimal number, because again, we're doing the conversion. So if we have an on bit at 128, we take 128 from our original number, subtraction, we end up with the number 12. Is 12 greater or equal to 64? It's not. It's way less. Off bit. Is 12 greater than or equal to 32? No way. Off bit. Is 12 greater than or equal to 16? No way. Off bit. Is 12 greater than or equal to 8? Yes, it is. And 8 does fit into 12. So, on bit. 12 minus 8 is what? 4. Is 4 greater than or equal to 4? It's equal to. So we're going to give it an on bit. And then now we're left with 0. So the rest are zeros. So we just converted the number 140 into binary. Now, do you see the logic and how we use this chart for all our conversions? Again, you're going to need to know this chart, especially when we get into subnetting. just so you guys can see the full picture. All right. Now let's go over the IPv4 address structure. So how do we make it unique? How do we know when a host is unique? Well, let's break that down. So in an IPv4 address, we're going to have two sections. We are going to have something called the network portion and the host portion. So what does this mean? The network portion is going to tell that device. So if I'm sitting here with this computer, I'm connected to this guy over here. We're on a shared segment. I'm assigned 10.10.10.25, and he's assigned 10.10.10.35. Now, just looking at those IP addresses, which numbers are unique? The 35 and the 25. Now, okay, the rest of the numbers are the same. They're not unique. So what does this tell us just using logic, right? Before we get into binary, subnet mask, network, and host portion. That means that these two computers both share this in common, so they're both part of this number scheme or this network. So they know, hey, buddy, me and you share these numbers in common. We're part of the same network. We're in the same hood, right? But I'm still unique in that I have a 25 at the end and you have a 35, which lets us uniquely identify each other. Now, here's the part we have to understand. How do these IP addresses know this? How do they know that these three numbers are going to be the same amongst each other? They base it off something called their subnet mask. And their subnet mask is going to decide where in their IP address is the network portion and where in their IP address is the host portion. Okay, so now let's break this down, right? So as we can see here in this subnet mask, all these ones here represent the network portion. So in our subnet mask, the ones, we know they're on bits, right, are going to equal the network portion. And in our subnet mask, the zeros are going to equal the host portion. Whew. So let's take a breath, right? So what did we just go over? We learned how to do conversion from decimal to binary, binary to decimal. We learned what makes an IP address unique is its host portion. We learned that IP addresses recognize when they're in each other's hoods or networks via their network portion. And these two portions are determined by something called the subnet mask. The subnet mask tells that IP address, that device, hey, you're a part of this network, and this network's allowed to have this many unique IP addresses assigned to it in the host portion. Okay? Now, how do we know that? Well, you see this host portion here, all zeros? The subnet mask is saying, hey, take all these zeros and add them up to your binary positional table, and that's going to tell you how many IP addresses you have in your network. Okay? Now, before we dive into subnetting too much, let's go over that. So let's clear up the screen a little bit. So again, we have our IP address here that's assigned to our host. Our host also has this subnet mask assigned. The ones in the subnet mask equal the network bits. Zeros equal the host bits. The subnet mask is telling that IP address, hey, buddy, you see this? These are going to be your network portion. So if you line it up to the IP address, we're saying that whole octet, all three of these whole octets, belong to the same network. Now your last octet, that's free play. So for the entire network, we have how many unique IP addresses available to us? Well, to find that out, we must add up these host bits. So if we write up our chart up here, right? And if we add up all these bits, let's say we place them under here and add them up. And again, this is for subnet mask, right? For the subnet mask. If we add all these numbers up, we're going to get what? 256, right? So that means we have 0 through 255, because 0 counts as 1, of unique IP addresses. We have 256 unique IP addresses that we can assign to devices that share our network. Whew, right? Let's take a deep breath, okay? And let's actually go ahead and pause this video. And then in our next video, we're going to jump right in to more about the subnet mask, default gateway, and other features, or I guess functions, or how IP addressing works in general.